Picture the moment. The body is placed into the chamber. The temperature climbs toward 1,400 degrees Fahrenheit, then higher, past 1,600, sometimes closer to 1,800 degrees. Within about 2 hours, everything soft, everything organic, every memory-carrying cell you ever built is gone. But here is the question almost nobody asks, and it is not the question you think it is. It is not a religious question at all. It is a physics question. Where do your atoms actually go? Richard Feynman spent his entire career obsessed with exactly this kind of question, and the answer he gave decades ago is stranger, more precise, and honestly more comforting than anything a funeral home will ever tell you. Today we are going to trace your atoms from your body, through the flame, and back into the universe, using nothing but physics, no religion, no speculation, just the same laws that govern every star, every ocean, and every living thing on this planet, applied honestly to the one event every single one of us shares. Before we go further, if the kind of channel that takes something as final and as frightening as death and actually explains the mechanics behind it, calmly, scientifically, without the dramatics, is the kind of content you want more of, hit subscribe now, because Smart Psychology puts out this exact kind of breakdown every single week, and you genuinely will not want to miss the next one. Let us start with what you actually are, physically, before any of this happens. Your body is made of roughly 7 octillion atoms. That is a 7 followed by 27 zeros. Of those atoms, about 65% are oxygen, mostly bound up in water, since your body is roughly 60% water by mass. Around 18% are carbon, the backbone of every protein, every strand of fat, every piece of DNA you carry. About 10% are hydrogen, again mostly in water and in the fats and carbohydrates that fuel you. Then smaller amounts of nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium, each one doing specific structural or electrical work, from firing your neurons to building your skeleton. None of these atoms are unique to you. None of them were manufactured for you. Every single one is billions of years old, forged either in the early universe or inside the core of a dying star, and every single one is simply on loan, passing through you for a while before moving on. Feynman used to describe this idea to students in a way that stuck with generations of physicists, saying that the atoms in your body today are not the ones that were there a year ago, that your body is more like a flame than a thing, a pattern that persists while the actual matter flows through it constantly, being replaced, breathed out, sweated away, shed as skin, and replaced again by atoms from the food you ate that morning. You are not a fixed object made of fixed material. You are a process, a very stable, very organized whirlpool of atoms that holds its shape for 70 or 80 years and then stops. So what happens when that whirlpool stops and the body is cremated? The process is essentially controlled, accelerated combustion, and understanding it atom by atom removes almost all of the mystery. As the chamber heats past around 100 degrees Celsius, the water in your body, the 60% of your mass that is essentially hydrogen and oxygen bonded together, begins to boil away as steam. This happens fast because there is so much of it, and it is the first major transformation your body undergoes. That water vapor rises through the exhaust system of the crematory and eventually disperses into the atmosphere, where it becomes, quite literally, indistinguishable from any other water vapor on the planet, eventually condensing into clouds, falling as rain somewhere on Earth, possibly being drunk by another living creature, possibly by another human being, within weeks. As the temperature keeps climbing past 300, past 500 degrees Celsius, the organic material, the proteins, the fats, the carbohydrates, all of it built primarily from carbon, hydrogen, oxygen, and nitrogen, begins to combust. Combustion is simply a rapid chemical reaction with oxygen, and the products of that reaction are almost entirely gases. Carbon combines with oxygen to form carbon dioxide. Hydrogen combines with oxygen to form more water vapor. Nitrogen, much of it, escapes as nitrogen gas, the same nitrogen gas that already makes up 78% of the air you breathe every day. These gases exit through the crematory exhaust, mix instantly with the surrounding atmosphere, and from that point forward they are simply part of the air. Not metaphorically, literally. The carbon atoms that were once organized into the structure of your muscle tissue are now floating as carbon dioxide molecules, indistinguishable from any other carbon dioxide molecule on Earth. And within days, some of those exact molecules will drift into a forest, or a field, or someone's backyard garden, and be pulled in through the stomacher of a leaf, and used by a plant to build a new molecule of glucose through photosynthesis. Carl Sagan liked to point out that the atoms in your body were forged inside stars, and the physics of cremation simply continues that same cycle, releasing carbon and hydrogen and oxygen back into circulation, so they can eventually become part of a tree or a blade of grass, or eventually another animal that eats that plant. It is worth going one layer deeper on where those atoms originally came from, because it makes the entire cremation process feel less like an ending and more like a return trip. Every carbon atom in your body, every oxygen atom, every atom of calcium in your skeleton was manufactured inside the core of a star through a process called nucleosynthesis, where enormous gravitational pressure fuses lighter elements like hydrogen and helium into heavier ones like carbon, nitrogen, oxygen, calcium, and iron. That star eventually died, often in a supernova explosion, and scattered those newly forged atoms across space as dust and gas. Over billions of years, some of that dust gathered together under gravity to form our solar system, our planet, the early oceans, the first simple organisms, and eventually, through an unbroken chain of biological inheritance, you. So when Feynman talked about atoms simply passing through you, he was describing something with a genuinely cosmic timescale. The calcium in your bones is older than the sun. The oxygen in your lungs has likely been part of ice, ocean water, dinosaur tissue, ancient forests, and human bodies going back tens of thousands of years, long before it ever became part of you specifically. Cremation does not interrupt that ancient cycle. It simply moves it along one more step, releasing atoms that have already traveled an almost incomprehensible distance and duration back into general circulation again. What does not combust, what cannot be turned into gas at these temperatures, is bone. Bone is built primarily from a mineral called hydroxyapatite, a crystalline compound of calcium and phosphorus, and this mineral structure can survive temperatures that completely destroy soft tissue. After the flame has done its work, what remains in the chamber is not ash, in the way a piece of burned wood produces ash. What remains are bone fragments, brittle, chalky, calcium-rich fragments, and these are mechanically processed afterward, ground down into the fine, uniform texture that people actually receive in an urn. This is worth pausing on, because most people assume cremated remains are literally the ash of a burned body, when the truth is more specific and honestly more interesting. What you are holding in that urn is almost entirely calcium and phosphorus, the mineral skeleton of a person, ground into powder, the carbon, the hydrogen, the water. The vast majority of the atoms that made up that living, breathing, thinking human being are not in that urn at all. They already left as gas hours earlier and are already circulating through the atmosphere and the water cycle of the entire planet. If you are finding this genuinely fascinating, and I think once you start thinking in these terms, it is hard to stop, this is a good moment to hit that subscribe button, because we go this deep into the actual science behind the biggest, most avoided questions of human life on this channel constantly. And if this one is landing for you, the next one probably will too. Now here is where Feynman's physics becomes less about mechanics and genuinely more about meaning, without ever leaving hard science to do it. Feynman was famous for insisting that nature's actual explanation for something is always more beautiful than the myth people invent to avoid learning it, and the physics of death is a perfect example. The law of conservation of mass and energy, one of the most rigorously tested principles in all of physics, states plainly that matter is never created and never destroyed, only converted from one form into another. When your body is cremated, nothing about that law is suspended. Every atom that made you up is still, at this very moment, somewhere in the universe. Nothing vanished. Nothing was erased. The carbon that was briefly organized into your body is now carbon dioxide, floating, waiting to be absorbed by a plant. The water that filled your cells is now somewhere in the atmosphere, in a cloud, in the ocean, in someone's drinking glass in another country. The calcium in your bones, if scattered, returns to soil, gets taken up by plant roots, and continues on, silently, without ceremony, without anyone noticing the exact moment it happens. This is not poetry laid on top of physics. This is what conservation of mass literally means. Feynman once described watching a leaf and realizing that the atoms making up that leaf had been, at some earlier point, part of the sun itself, carried to Earth as light, absorbed through photosynthesis, and rebuilt into carbon-based plant tissue. He found that fact almost unbearably beautiful, not because it was mystical, but because it was true and provable, and something you could calculate. Death, looked at through this exact same lens, is not really an ending in the way most people picture it. It is a release. The extremely specific, extremely temporary arrangement of atoms that constituted you, the pattern that let you think, feel, remember your childhood, recognize your own name, that pattern stops. But the atoms themselves simply rejoin the general circulation of matter on Earth, the same circulation they were part of before you were ever born. There is a statistic that Feynman-era physicists love to use to make this point vivid, and it holds up mathematically even today. Because the atmosphere mixes so thoroughly over just a few years, and because the human body releases such an enormous number of atoms through breathing, and eventually through death, calculations based on Avogadro's number suggest that every breath you take right now almost certainly contains at least one atom that was once exhaled by a historical figure like Julius Caesar or Cleopatra, or anyone else who lived and breathed on this planet more than a couple thousand years ago. And by that same logic, atoms from every person cremated this year will eventually mix into the breathable air of nearly every other person alive, given enough time for global atmospheric circulation to do its work. The math is not a trick. It comes from the sheer number of atoms in a single breath, roughly 25 sextillion molecules, compared with the total number of atoms cycling through Earth's atmosphere over thousands of years. You are quite literally right now inhaling atoms that were once part of people who are considered ancient history. Cremation simply accelerates that same natural process for one particular person, releasing a large quantity of atoms back into circulation over the course of a couple of hours instead of the slower decades-long release that happens through ordinary breathing and decomposition. This connects to something physicists call entropy, the measure of disorder in a system, and it is central to understanding why cremation feels so final, even though nothing physical is actually destroyed. Your living body is an extraordinarily improbable, extraordinarily low entropy arrangement of atoms. Keeping that arrangement organized, keeping trillions of cells cooperating, keeping proteins folded correctly, keeping your heart beating in rhythm, requires a constant input of energy fighting against the natural tendency of every system in the universe to drift toward disorder. This is the second law of thermodynamics, and it applies to everything, including you. The moment your body stops actively fighting entropy, decomposition begins immediately, whether through burial or cremation, and cremation is simply the fastest possible route back toward disorder, using heat to violently accelerate a process that would otherwise take years underground. The atoms do not care which route they take. Buried, they are broken down slowly by bacteria and fungi over years, and the same carbon, hydrogen, and nitrogen eventually escape as gas anyway, just far more slowly. Cremated, the exact same atoms escape as gas within hours. The destination chemically is the same, only the speed changes. It is a little like comparing a slow leak in a tire to popping it all at once. The air ends up in the same place either way, outside the tire, mixed with the surrounding atmosphere. It is simply a question of how quickly that transfer happens. Researchers who study human decomposition, sometimes at facilities nicknamed body farms, have documented this slower pathway in remarkable detail, tracking how bacteria first consume the easily accessible carbohydrates and proteins, how insects accelerate the breakdown of soft tissue within days in warm climates, and how eventually only bone and some connective tissue remain after months or years, depending heavily on soil composition, moisture, and temperature. Cremation essentially compresses that entire multi-year timeline into roughly 2 hours of intense heat, which is precisely why the end products look so different from what most people picture when they imagine a body decomposing naturally, even though the underlying chemistry, oxidation, the breakdown of complex organic molecules into simpler gases and minerals, is fundamentally the same process running at a dramatically different speed. This is also where the psychology genuinely intersects with the physics, and it is worth sitting with for a moment. A huge amount of the fear people carry around death is not actually fear of the physical process itself. It is fear of disappearance, the idea that the specific person, the specific mind, simply stops existing and leaves nothing behind. But when you look closely at what a mind actually is, physically this fear starts to shift shape. Your thoughts, your memories, your sense of being you, are generated by roughly 86 billion neurons in your brain, firing electrical and chemical signals across trillions of connections. Those neurons are themselves built from the exact same borrowed atoms as the rest of your body, constantly being replaced, with most of the actual molecules in your brain tissue turning over within months or years, even while the pattern of connections, the thing that actually stores your memories and your personality, remains relatively stable. This means that even while you are alive right now, you are not made of the same atoms you were made of a decade ago. What has persisted is not the material, it is the organization, the pattern, the specific arrangement of connections that your brain has built and maintained over your lifetime. Death, from this angle, is the moment that organizing pattern stops being actively maintained, and cremation is simply the fast dispersal of the raw material that pattern had been temporarily borrowing. This does not erase the emotional weight of losing someone, and nothing in physics is meant to minimize grief, which is a real and important psychological process on its own. But understanding the mechanism does something specific and useful. It replaces a vague, formless fear of nothingness with a concrete, physically accurate picture of continuation, and for a lot of people, that concrete picture is genuinely easier to sit with than the vague one. There is also a genuinely popular modern practice worth mentioning here, because people often ask about it once they understand the chemistry, and that is the idea of turning cremated remains into a diamond. Several companies now offer this service, extracting carbon from cremated remains and using extreme heat and pressure to grow a synthetic diamond from it. The honest scientific caveat, the one most of these companies do not lead with in their marketing, is that the vast majority of a person's carbon has already left the body as carbon dioxide gas during the cremation process itself, since the flame specifically targets and burns off organic carbon. What little carbon remains in bone fragments is a small fraction of what once made up your living tissue. So companies offering this service typically need to supplement the process, and are transparent about that if you look closely at their actual procedures. It is a beautiful idea, symbolically, but understanding the actual chemistry helps you see it clearly for what it is, rather than what marketing implies it is. Feynman was not a spiritual man in the traditional sense, and he was famously blunt about death near the end of his own life, reportedly telling people close to him that dying was boring, meaning simply that it was just a biological event, not a mystery requiring elaborate explanation. But in his lectures and writings, he circled back again and again to the idea that understanding the actual mechanism behind something never makes it less meaningful. It makes it more meaningful, because you are no longer afraid of the unknown, you are simply looking clearly at what is actually happening. Applied to cremation, applied to death generally, this reframes the entire event. The atoms that built you, that let you read these words right now, that let your brain generate the specific pattern of electrical activity that makes you, are ancient, are borrowed, and will continue on in new arrangements long after the particular pattern that is currently reading this sentence has ended. That is not a religious claim. It is simply thermodynamics and atomic physics described plainly. So where do your atoms actually go? To answer the question directly, the water in you becomes clouds and rain, and eventually someone else's drinking water. The carbon in you becomes carbon dioxide, gets pulled into a leaf through photosynthesis, and becomes part of a new living thing. The nitrogen returns to the air, ready to be captured by soil bacteria, and eventually built into a new plant's proteins. The calcium and phosphorus in your bones, if scattered rather than kept in an urn, return to soil and are drawn up by roots to build the next generation of trees and grass and crops. None of it disappears. All of it continues, obeying the exact same conservation laws that govern those atoms before you were ever assembled out of them, for a few short decades, into someone capable of loving people, building things, being afraid, and eventually wondering exactly what you are wondering right now. If any part of this changed how you think about the ending of a life, that is genuinely the entire purpose of this channel, and the best way to support more videos like this one, breaking down the biggest, heaviest human questions using actual, verifiable science instead of vague comfort, is to subscribe, and to share this with someone who has been quietly afraid to think about this exact topic, because a lot of that fear tends to come from not understanding the mechanism, and understanding the mechanism, as Feynman proved over and over throughout his entire career, is usually the thing that finally makes the fear make sense, and then quietly loosens its grip. Your atoms were here before you, and they will still be here after you, doing what atoms have always done, moving, combining, building something new. You were never really separate from that process. You were just a particularly organized, particularly aware moment inside of it, and in a very real, physically provable sense, you never fully leave. Feynman spent his life trying to get people to see the ordinary world with this kind of clarity, insisting that a genuine understanding of how something works never subtracts from its wonder, it only adds to it, and there is arguably no better test case for that idea than the ending of a human life examined honestly, all the way down to the atoms.